Let's welcome the second group, and the topic is AI-powered PySCF Alchemy.
So hello, everyone. Today we're going to tell you all about a little product that we've done in the past 2 days, which is called MCP to PySCF. It's an AI-powered PySCF Alchemy, and I'm Lixin, and this is Andrew. So we actually tried to invite some other group members from our group to join this hackathon, but they are busy over the weekend, so we kindly asked Gemini, and Gemini accepted the invite. So that's one of our team members as well. We are from a group that does quantum chemistry, and we develop electronic structure theory. So what is quantum chemistry? It's easy. We try to use quantum mechanics to understand chemistry and all the chemical reactions in our life and nature. So we basically just need to solve the Schrodinger equation here, which is H psi equals to E psi. And I think all of you knows that it's impossible with our current computational techniques and resources to solve this equation fully. Therefore, as a theoretical chemist, we actually have already developed a toolbox of different methods, including from low-level Hartree-Fock/DFT all the way until the most expensive full CI, which is the full configuration interaction that supposedly give us the most correct answer. So here, the benefit here is that we can predict the properties and behavior of atoms, molecules, and everything we want from most fundamental physical laws. So imagine we don't do any experiment anymore, but we know the answer in front so that we can directly go to our target. So because of this benefit, this has already become an indispensable in scientific discovery. So first area, of course, is in material science. We design batteries, we find catalysts. And also another area will be drug design, which some famous tech company has already stepped into this field to create their own products to advance the field using quantum chemistry. So however, quantum chemistry is a complex science because it involves a very steep learning curve, and we need to know not only the chemistry or quantum mechanics, we even need to know all the computational knowledge in computational sciences. So there also are various quantum chemistry packages in the past 50 years, and it includes very complicated workflows for each of them. So that usually in the past requires a full PhD training in a group specialized in one package. So my PI actually said after LLM's birth, maybe soon we don't need any PhD students anymore. So anyway, here, fun enough this weekend, we then get the chance to build an AI-powered assistant that leverage large language models using MCP here to intelligently control this powerful quantum chemistry package PySCF. As its name indicates, PySCF is written in Python. It's a fully Python-enabled interface with all the most important computational high-cost parts, such as computer integrals coded in C. So with all this beautifully written Python interface, now in our MCP to PySCF, it can now run single-point calculations and perform geometry optimization. And it can also further go ahead to analyze the results, plots the calculation outputs, and also the molecule geometries. So here is the GitHub repo about its composition, but let's just first try it out. So this is the two prompts that we'll try, or actually I can also just show how it looks like after we tried in Lixin. I need to. So here, if we give a prompt, say, use the tools I have provided, plot a potential energy curves of nitrogen molecule from 0.8 to 2.0 angstrom. Here it starts to think, and it runs the corresponding tools that we build. And then the output, it's a series of bond length and its energy. Of course, then the next step, MCP or the LLM model actually find the correct plotting functions. And this is the output plots that it created. So basically now we use natural language to ask the package to run a full from calculation to analysis picture. And now we find equilibrium bond length. The next functionality we want, of course, is the geometry optimization, which is another commonly used functionality. So here, when we say do a geometry optimization for the molecule with SMILE string, here For people who doesn't know what is a smart string, it's basically the dictionary for a majority of the molecules that we know, giving a name tag. So for example, CO here corresponding to a 6-atom molecule. And after performing the optimized geometry, it gives out the output as a string of geometries, and then it calls the visualization. But here again, because this LLM says a read-only file, I couldn't write HTML, but indeed, we are able to save the HTML into a file. And if we click this open, we're able to visualize the optimized geometry on the HTML web page. So basically, here we showcase our product. Let's go back to the slides. At the end, the conclusion is with the MCP tool here we plugged in, there's no need to have custom interface to different LLM modules anymore to connect to different software packages. And then we also now make the predictive power of quantum chemistry more accessible for people who doesn't need to do a PhD in theoretical chemistry. And we therefore enable much faster discovery in material science and drug design. But furthermore, move forward, I find this project interesting also because, again, PySCF is Python written. So if we actually link each of the PySCF function, make it MCP tool, we can actually now use LLM to directly call the functions inside PySCF rather than me writing the functions to call PySCF functions. So that actually will make it have a fully functional for our purposes. Okay. Thank you very much.
Yeah, I want to mention that it's not just us. Like anyone should be welcome to ask questions. So, like after the AI did this work,
yes.
Say if I need to do further work,
yes.
How do I continue? Like the data saved somewhere, and I can continue working on it.
So here, basically, we all the data will be output as a string. But if the data is too much, we also further plan to save it into CSV files, etc. And there's another feature that we consider is to save the PySCF input, because LLM may not be able to access to large computing resources like GPU, for example. Then we can then get the input and run it ourselves. But that's also strongly simplify the process that a person need to run calculations.
Question.
Yeah.
How involving is it to create this MCP server? Does it take a PhD training to understand the package and write this interface?
I got a PhD training, yes. But on the other hand, PySCF package itself has very detailed documentation. And also the inside the code has already have full like argument list. It's just not really enabled by the MCP tool. So I think it should be really easy and straightforward to just link those together.
Okay, what percentage of PySCF do you now have access to through this? It's a package with many capabilities.
Yes, yes. So you mean currently? Yeah, currently we didn't write too much interface in between, but that's why I said moving forward, we should just add the MCP tool inside the PySCF to fully expose all the functionals rather than writing interface for each of the functionality. Yeah, so the LLM can then call each functions based on their own decision.
Another quick question.
Yes.
So if the package has well-defined documentation interface for the functions, do you think it's possible to automate this process? Because it's basically re-describing the functions and interface into an MCP server.
Yes, yes, I think it's very great for automation. For example, here, when we ask in one prompt, it actually calls multiple functionalities already. So it should be smartly picking the functions itself.
Well, I'm asking this building this MCP server, this process.
Oh, yeah, yeah, yes, definitely. That's a good point. Thank you very much. Yeah.
And also, if other people have questions,
yeah.
I just had a question. So for example, this nitrogen examples that you had.
Yes.
How many functions did it need to call to be able to do that?
Basically, you just need to put in the geometry and select the basic set, and then that already construct the necessary classes for PySCF. And then in the function, it just calls the energy evaluation. Yes. So it's a construction part that's a little hard that you need some knowledge to do. Thank you very much.